All right, let's try and solve this integral here. To begin with, this is involving cosecant and cotangent. And just like there is a relationship between tangent and secant, there is an also very nice relationship between cotangent and cosecant. So let's recall what we know about tangent and secant first. We know, first of all, that the tangent squared x plus 1 equals to the secant squared x. That's something we know. This is one of the most important Pythagorean identities that we have, along with sine squared plus cosine squared equal to 1. And we also know that the derivative of tangent, right, equal to the secant squared x. In turn, we also know that the integral then of secant squared x is the tangent, right? So I'm not going to write both, but you know that they're both equivalent. For cotangent and cosecant, we have a similar relationship. We have that the cotangent squared x plus 1 equal to the cosecant squared x, and that the derivative of cotangent is minus cosecant squared x. So just the minus sign there is the only difference. All the rest is the same. I trust that you have this one down, that you remember this, and I also think you should remember that one. Once you have this green one down, remember it's very easy to also remember that, because then you know that the co-functions behave the same way as the original ones, as tangent and secant. If you need to prove these, it's also very simple. You just go about writing cotangent as cosine over sine, and then cosecant as 1 over sine. And you can verify this easily using the one that I mentioned, sine squared plus cosine squared equal to 1. And you can do the same thing here. You can write the cotangent as cosine over sine, and you derive that using the quotient rule, and you obtain the cosecant. And remember that the cosecant is 1 over sine, so that's okay. With this in mind, right? This in mind, we can start working on the problem. So all of this is just prerequisites, stuff to remember for us to solve the problem. So let's actually solve it now. Have the cosecant to the 4th of x dx, and then the cotangent squared x. We have now the integral. I want to make sure that I make use of these purple identities. I know that the derivative of cotangent is cosecant squared, so that would suggest the possibility of using u equal to cotangent x if I can make a cosecant squared show up somewhere. So that would be a part of the du term using a substitution rule. So if I split the cosecant to the 4th as cosecant squared x times cosecant squared x dx, and that divides by cotangent squared x. This here could be a du term if I make u equal to the cotangent x, right? The difficulty now is that I have this cosecant squared, so what I have to make sure is that I have to use this first identity to replace the cosecant squared with a cotangent squared x plus 1 divided by cotangent squared x, then cosecant squared x dx. So that will then allow me to use a u substitution, right? So I will make u equal to cotangent x dx, which means then that du, the derivative of cotangent, like we said, is minus cosecant squared x dx. So this is exactly that, with a minus sign, right? So I can write this as big minus sign outside, u squared plus 1 over u squared du. So if I divide, use distributive property for division, u squared divided by u squared is 1. 1 divided by u squared is u to the minus 2. I can then use the reverse power rule. So this will be a u plus a, add 1 to the power, so minus 1, and divide by the power, minus 1. Distributive property to the minus sign. Don't forget to add the constant at the end. It's minus u, and then plus u to the negative 1, plus c. And remember that u was the cotangent, so we have that minus the cotangent x plus 1 over the cotangent x plus c. This is fine. I will accept this. But you could also write it as 1 of the cotangent. This is the reciprocal of the cotangent. That's the tangent, right? So I write this as that, and then I subtract the cotangent. This I think looks a little better. There are some people who would prefer doing it differently. I've seen several different answers to this, final answers, but all of the final answers that you can find will be equivalent format or equivalent expressions, meaning they have the same value. So I hope this clarified, and I hope that you can find your own way to solve this. Just make sure that you're down with the particulars, the identities, the derivatives, because I could easily change this into something like maybe instead of a cosecant and a cotangent, I could write secant and tangent, or somehow find a combination of sine and cosine or something similar. It's very easy to change this type of question. So make sure you get the fundamentals down.